Hi, this is Manmad. Welcome back. Now we will discuss about the steps involved in producing effluent wastewater treatment process. The first one is bar syringe number, and the second one is island grease trap. Third one is equalization tank, and fourth one is flash mixture. Fifth one is primary settling tank. Sixth one is anaerobic degradation or anaerobic tank. And seventh one is biotower mechanism. Eighth one is aeration tank or SAF reactor, submerged aerobic fixed film. This is an advanced technology. And the ninth one is secondary clarifier. Then 10th one is multi-grade filter, which contains sand and carbon adsorption method, of course. And 11th one is treated water tank. And 12th one is sludge drying beds. Let us go in details about these steps. So let us go in depth, stepwise. The first one is bar screen chamber. So bar screen chamber, before entering, the sewer lines, the wastewater through the sewer lines, before entering into the collection tank or equalization tank, we have to equip the bar screen chambers at the entry point. Why the main purpose of equipping the bar screen chamber is to remove the macro particles. In seafood industry or shrimp processing industry, what kind of macro particles can be generated? The major macro particles can be generated in shrimp industry is shell waste and nitrile gouges fragments, polythene waste and paper waste. These are the major macro particles can be generated during the shrimp processing or seafood processing, or some visceras or something. If it's fish, there something skills are there. And the mechanism also, every section we have a trapping mechanism. If accidental fall of shell waste into the drain, and it will be retained at the end of the section, drain trap, they will clean. And sometimes maybe accidentally, which can escape from the drain trap, goes up to the effluent treatment pan. So the bar screen chamber will retain the macro particles like shell waste or polythene waste or gouges waste or paper waste. So we have to remove at frequent intervals, and we have to clean the bar screen chamber as and when required. Daily, once or twice or thrice, depends upon the load we generate during the process of treating the products. So that's about the bar screen chambers. In seafood industry or shrimp industry, bar screen chamber with a size of mesh size 25 mm to 40 mm is more enough to retain the most of the particles, macro particles. Yes. And the second step is island trap. Through the gravity, so oil or something, any grease, because of the process. So we have to remove the oil or grease. Oil is like a buoyant nature which can float on the surface of the water. So just on the top of the water, if you fix the if you fix the separator, and which can easily retain the oil and grease. So frequently we have to clear that the top layered oil and grease. And this also, bar screens also, if we cannot equip, then it will interrupt the process. If once polythene waste enters inside, or plastic waste, or what will happen, it will interrupt the entire process. Now the third step is equalization tank. To make continuous, constant, homogeneous feed flow to the biological system, equalization tank will be very helpful. So what we have to do is, every effluent treatment process, every effluent system in seafood industry should have more than one equalization tank. Once the one equalization tank is filled up, then close the inlet pipe and divert the water to the equalization tank too. In the meantime, we have to run the aerations continuously. So we have to make sure that aeration tank run continuously to neutralize the chlorine residuals. Once we make sure that the chlorine residues in equalization tanks completely gets neutralizes, then we have to pass to the flocculation channel or flash mixtures. Means chemical dosage also we have to add that. Here effluent will attain average organic concentration. Then after equalization tank, the wastewater goes to the flash mixture or flocculation chamber. Flash mixture or flocculation chamber. Here what we have to do is, we have to add settling agents or floatable agents. Means the wastewater contains suspended particles like TDS, TSS, lot of colloidal particles also there. So we have to add ferric aluminum sulfate. Ferric aluminum sulfate is nothing but alum. And the second one is polyelectrolytes also can be used. So what happened? Once you add the ferric aluminum sulfate in the wastewater, which will enhance the settling particles, to settle down and reach to the bottom. The settling particles gets weight and it will settle down the bottom and form as a sludge. And if we add the polyelectrolytes, flocculants like polyelectrolytes also can be added flash mixture. So this what will happen, it will enhance the formation of floatable solids on the surface. So after that, so here we have to here dosing nozzles are there, dosing pumps are there. Once the effluent is from equalization tank through the flash mixture, it goes to the primary clarifier. Through the process, continuously drop by drop, the chemical doses will be added, like ferric aluminum sulfate and polyelectrolytes. So settleable solids can be settled on the bottom and floatable solids can be formed on the surface as a floccules. So which can be easily removed in the next process. Primary settling tank. Settle down any suspended particulate matter in the wastewater. Because in the flash mixture or flocculation chamber, we have already added the ferric aluminum sulfate like alum and flocculants like polyelectrolytes. So which will enhance the settling process of settleable solids and which will enhance the floating process of floatable solids. Okay, floatable solids is nothing but floccules and settleable solids is nothing but the sludge. It's a physical process. Primary clarifier is nothing but it's a physical treatment process. Before it goes to the wastewater to the biological system, the settleable solids can be removed by the sludge formation and floatable solids is nothing but the scum can be removed by the skimmers. So in this primary settling tanks, on the top of the primary settling tanks, skimmers will remove the floatable agents or floatable solids, and the bottom sludges also can be removed and diverted to the sludge drying bed. So this is how the process takes place in the primary settling tank. In primary clarifier, 90% of the settleable solids, 40% of the suspended solids and 25% of the total BOD can be removed. Now the next step is after primary settling tank, then the effluent water goes to the anaerobic tank or anaerobic degradation process. What to do is the effluent from primary clarifier goes to the anaerobic tank. Anaerobic tank we have to put PVC biomedia. PVC film which contains biomedia means microbial flora, they will embedded into the PVC biofilm. So once you put inside the anaerobic tank, once the effluent water enters into the inside the anaerobic chamber, the flora which is embedded in the PVC biomedia, which will degrade the organic waste present in the effluent water, dissolves the organic waste, decomposes the organic waste, and finally the organic waste turn to methane, carbon dioxide and water vapor. And at the bottom of the aeration tank, we have to provide the drain valve. So sludge generation. So at frequent intervals, we have to divert the sludge to the sludge drain beds. So this is the anaerobically the bacteria which are invading in the PVC biomedia or PVC biofilm, which can degrade the organic waste contains in the effluent water. So finally, the organic waste turns to the methane and water vapor. Then the next, the water, effluent water goes to the biotower. Seventh step is biotower. So biotower contains PVC biomedia. So aerobic bacteria, in that contains aerobic bacteria. That's why in biotower you should always maintain dissolved oxygen level at least 2 mg per liter. So once the effluent water goes to the biotower, and on top of the biotower, water sprinklers are there. The wastewater sprinkled on the PVC biomedia. So the PVC biomedia contains microbial flora, aerobic bacteria, which will degrade the organic waste. So biological degradation will takes place. Sometimes whenever there are whenever there is no production for more than weekdays of time or 10 days of time, we have to make sure that lengthy shutdowns like more than weekdays, we have to add the feed to the biotower as well as aeration tank. So we have to make sure that continuous feed flow to the biotower as well as aeration tank at least once in a week if you are lengthy shutdown period. Why? Because this biotower contains PVC biofilm. PVC biofilm means PVC strips, biofilm embedded in the PVC strips, which are aerobic, which will degrade the organic waste. Organic waste means organic waste nothing but the proteins, carbohydrates and fats. Got my point? Yes. Then in the lengthy shutdown period, we have to add some jaggery. You have to mix the jaggery in the water, urea and DAP and pass through the feed plumb. So, which will give the feed to the microbial flora if lengthy shutdowns. In the same process, you have to apply urea, DAP and jaggery to the aeration tank also. If no feed flow, if no feed flow or if no effluent flow for more than a week or for more than 10 days, then the entire biological degradation system will deteriorate. Every food facility is investing lakhs of rupees to equip the SAP system. 20 lakhs, 30 lakhs depends upon the aeration tank size, and SAP system means nothing but submerged aerobic fixed film. So if you are not maintaining the feed flow continuously, then the entire flora gets deteriorated, gets dead. Now aeration tank. Here aerobic degradation will occur. Aeration tank. So the effluent water from biotower goes to the aeration tank. Bottom of the aeration tank contains air diffusers, which will generate and maintain the oxygen levels in the entire system. So we should always maintain 2 mg per liter or above oxygen levels in aeration tank as well as in biotower. Now most of the seafood industries or food processing industries have equipped SAP reactor mechanism in aeration tank. SAP is nothing but submerged aerobic fixed film. It's a hybrid technology where attached growth activity and suspended growth activity can be taken place simultaneously. So in the SAP reactor contains PVC biofilm or PVC biomedia. The PVC biomedia contains nothing but the microbial flora, aerobic bacteria. Whatever the leftover BOD from after biotower to aeration reaches, then the bacteria, aerobic bacteria, which are embedded in the PVC biomedia, will degrade, biologically degrade the organic waste. And whereas suspended growth also will take place. And the SAP reactor system is like hybrid mechanism. And whenever there is no feed effluent for more than 1 week or 10 days, so we have to maintain the feed effluent to the microbial flora, biological. Otherwise, what happened? If there is no production more than 10 days, you have not you have not given any feed effluent to the system, then the bacteria will die. Like log phase, lag phase, exponential phase, and declining phase. So this is how. If there is no feed, there is no continuous feed flow, then finally the bacteria will reach us to the declining phase. Then again you have to purchase the SAP reactor with by PVC biomedia. It's lakhs of rupees, 30 lakhs or 20 lakhs, 40 lakhs. Most of the industries are investing per year 1 crore to purchase the PVC biomedia or PVC biofilm. But no use if you are not maintaining the continuous feed flow. Whenever there is a lengthy shutdown period in the processing facility, more than weekdays, you make sure what you have to do. Take 5 kg jaggery, mix in 500 grams of urea and 100 grams of DAP. You add to the aeration tank regularly. Daily you have to add 5 kg jaggery, 500 grams urea, 100 grams DAP. You have to dissolve in the water and pour it into the aeration tank. So which will generate the feed flow, which will fulfill the requirements for the microbial growth. So you can maintain the growth cycle in an exponential stage, lag phase to exponential phase. Growth cycle should not come down to the decline phase. If it comes down to the decline phase, then biological process will retard. And here also the bottom outlet is there. During the process, MLSS process, mixed liquor, suspended salts or sludge activated salt process. So some amount of sludge will be generated on the bottom of the outlet, and through the bottom outlet we have to divert the sludge to the sludge drying beds. And again the process continues same. So after aeration tank, the effluent or wastewater goes to the secondary clarifier. So secondary clarifier also same like primary clarifier. Here also the top circulator skimmers are there, and bottom also sludge water, the generated sludge is there. It will goes to the sludge drying beds. And the top, whatever the flocules formation on the top, removed by the skimmers. On the top means scum formation will occur on the top, sludge formation will occur at the bottom. So through the gravity, through the activity of the gravity, scum will be removed by the skimmers and sludge will be removed by the outlet, bottom drain outlet through the sludge drying bed process. This second step. So after clarified water goes to the multigrade filter. Multigrade filter means which contains carbon filter and sand filter. As I said, in seafood industries, so there are not only the organic waste during the process of shrimp industry, during the process of fish, some amount of inorganic waste also will be generated. Inorganic waste. Organic waste is okay, biological degradation will occur, and anaerobic oxidation or aerobic oxidation, biosystem is there. Whatever the inorganic waste. So you have to equip MBR technology. You have to equip MBR technology after the aeration tank. So once the aeration process, biological degradation through the aerobic bacteria takes place, then the water goes to the MBR technology, membrane filter technology. Here synthetic membranes are there. Whatever the waste or inorganic waste or whatever the particles which are bigger than the membrane filters, so which can be retained through the process of reverse osmosis. See like chloride ions might be there, magnesium ions might be there, okay, phosphates and citric acid, lot of chemicals we are adding during the process, inorganic waste. So organic waste can be degraded by biological system, whatever the inorganic waste. So to minimize or to reduce the inorganic load in the process water, we must equip membrane technology, membrane filtration technology. It's through the process of reverse osmosis, the inorganic load can be reduced. Either maybe TDS or TSS, whatever it may be that. If water contains chloride is more, most of the seafood and shrimp industry are using chlorine. And salts also they are using. Salts contain sodium and chloride, which are adding into the system. If chloride content is above 500 ppm or above 600, 700 ppm, even the bigger trees also cannot survive. It destroys the growth of bigger plants and reduces the crop yield also. Big plants also, due to the toxicity of chloride content in the soil, gets deteriorate. So plants will become die. So in that point of view, after aeration tank, we have to equip MBR filtration technology. Inorganic load can be reduced through the MBR filtration technology, which cannot be removed by the biological process. Okay. Then after that, after MBR process, then the water goes to the secondary clarifier. So most of the load can be removed here. Inorganic load, inorganic waste can be removed here. Then after secondary clarifier, it goes to the multigrade filter. Yes, we must equip multigrade filter. Why? Because the water contains lots of impurities. TDS might be there, TSS might be there, and other colloidal particles also there. So the multigrade filter is nothing but sand filter and carbon filter. Sand filter means what? Like, see, the macroparticles like manganese and iron also can be removed by the sand filters. And carbon filters, saturated carbon filters will absorb the impurities in the water. Then after, and this carbon filter also will absorb some amount of inorganic waste also. Inorganic waste also will reduce once you pass through the mixed grade filter. So it is better, it is advisable to equip MBR technology as well as mixed grade filter. So we can ensure that the water is suitable for irrigation. We can ensure that the water can be directly added to the water bodies. There is no any harm to the environment. Okay. After mixed grade filter, the water goes to the chlorine dosage tank. Here you have to maintain 2 ppm chlorine. So whatever the bacterial load is there, which can be reduced as chlorine dosage tank. After chlorine dosing, then the water goes to the treated water tank, treated water sump. From treated water sump, then you can irrigate through the tankers. You collect the water and irrigate. If you have the within the facility, you have the agri fields, then you can directly use the water for irrigation. That's all about the video. Thank you, universe.